one way or the other. We learn about totally new things, and it's very instructive. I think today is even special, with so many of you here, with Simon having produced his book about Elliot's, going to tell us about it. And another reason why Simon is special is because not only has that book been produced and published, he's now working on another book, which will be a BCS publication on Turing and the other pioneers. It will be a booklet published by the BCS next year, edited by Simon and contributed to by Roger Johnson, Martin Campbell-Kelly. Kevin, are you a contributor? Yes.
And Chris.
But you've got some jolly good authors there. So we never rest. Simon doesn't anyway. So, Simon, welcome. We look forward to your talk.
Thank you, David. Yes, good afternoon. I fear we've got a lot to get through this afternoon, and there's the agenda. I'm going to spend quite a lot of time on what you might call the background, rather than diving straight into the Anunnaki things, although rest assured there will be one or two Anunnaki things towards the middle and the end. As it says there, the first thing is to establish this company called Elliot, which became Elliott-Automation, and also to set the computers that they built in the computing landscape of the late 40s, early 50s. As for the computers themselves, there's a picture gallery, and we'll whip through those so that you can visualize exactly what we've been talking about early on. And then the Anunnaki bit will be my selection of one or two of the Elliot ideas that seem to have lasted a little bit longer than just the 1 or 2 years of their introduction. And finally, some items for further research. So this company, Elliot Brothers, the photograph shows their works at Lewisham in South London, pictured just after the end of the war. By then, the company was by then almost 150 years old, having been founded by William Elliot in 1804, an instrument maker. And Elliots were instrument makers. Obviously surveying and geometric instruments to start with, and then electrical, telegraph, navigational instruments, you name it, there they were. By the middle of the war, more than 4,000 people worked at that site. There's an interesting little building. Why doesn't, oh yes, there we are. I don't know whether you can see this moving red dot. That little building, I'll talk a little bit more about later. As the photograph caption said, this was erected by the Admiralty for their special purposes. Anyway, at the end of the war, by 1946, Elliot's was on its knees. There was a lack of confidence in senior management. This is especially poignantly pointed out by a government report, 1943, on morale and the effectiveness of the company. The report, incidentally, was labelled not to be revealed for 100 years. So, not quite sure why it is that I got hold of it. Possibly because the word Elliot was spelt incorrectly and therefore didn't feature in the cataloguing at the National Archives. At any rate, by 1946, the company was trading at a loss, and indeed remained at a loss for the next 4 or 5 years. It was down to 800 employees, and crucially, for this stage in our industrial history, there were no electronic skills in the company. And that was because, as I'll discuss later on, Elliots were into electromechanical things, particularly naval fire control, electromechanical analog computers. So what happened to pull the company around? Well, it was up to two people. Two people whose body language in this photograph of 1951 suggests that they didn't always get on with each other. And yet, in their ways, they were both essential to the well-being of the company and were, in their own fields, outstanding people. On the left is John Coles, scientist, who by the end of the war was in charge of the Admiralty's radar work at the Admiralty Signal School in Surrey. An enthusiastic person, a forward-looking, inspirational man. On the right is Leon Bagrit, who arrived, he was born in the Ukraine, he arrived in this country aged 12, not speaking a word of English. By his own efforts, he pulled himself up by his bootstraps, as it were, eventually running his own company called B&P Swift, which, although to start with was into food processing equipment and weighing machines, during the war had a lot of defence contracts, particularly actuators for aircraft demanding highly accurately machined gears, etc. And he was on the up and up. He was, by this time, an entrepreneur. So, let me tell you a little bit about the background of these two people, and then we'll see how their contributions came together to produce Elliott-Automation. So first, John Coles. At war's end, he, and I guess with Admiralty support, had this whizzo idea for how to improve the shipborne gunnery control, fire control equipment. And the project was called MRS-5, Medium Range System 5, and at the heart of it was a digital computer. Remember, this was 1945, early 1946, when up to that point all the fire control equipment in all three services had been analog and usually electromechanical. So the thought that they should have a digital computer at the heart of this was, to say the least, unusual. And briefly, what happened was that there was a sophisticated radar here on the right, which tracked approaching enemy aircraft, following their path from 8 miles out onwards, sent back to the computer information about bearing range and elevation, and indeed the sine and cosine of the angles as well, to save a bit of computing time. And what with one thing and another, other information like ballistics information and ship's gyro information, the central computer was required to update fusing and aiming information to the ship's guns every 200 milliseconds. So quite a challenge, an enormous challenge for those days. How did he proceed? Well, with the Admiralty's help, he was, as it were, not personally given, but the Admiralty rented to him, his group, a redundant wartime fuse factory at Borehamwood, a shadow factory. This photograph is of the mid-1950s, by which time a lamppost had been put up and that sort of thing. But one must imagine that in 1946 it was a bit more rural than we see here. The Admiralty chose for this particular development not to do it in-house at a research establishment under its own control, but to have the project under the umbrella of a company. And the first company that they chose to approach was, in fact, Armstrong Whitworth. You'd appreciate that it would be the heavy engineering and the arms manufacturers and the electronics companies who were first approached, but nobody would take it on, and the Admiralty, with some reluctance, went to Elliot, who agreed to be the parent organisation under whose nominal umbrella this laboratory, this building factory at Borehamwood, was set up as a laboratory. And John Coles, with 45 staff, moved in on 1st of October 1946 to start work. With some success. 5 years later, he was up to 350 staff, over half of whom were scientists and engineers, white-collar people, and a further 35% blue-collar people, so quite a good concentration of highly skilled and motivated young people, working on secret contracts. everybody from foreman and above had to sign the official secret statement. So what went on in Borehamwood? Well, the first task was to design this tracking radar, and for that, the radar people within Cole's group came up with a novel lens system for a radar. You may just see in this egg box-like structure 4 little shallow depressions, and you can imagine, without knowing anything of the technology, that the idea was to produce signals that detected the up-down, left-right deviation of a target from where the radar was pointing, and thus had information to move the radar to follow the moving target. That radar system was put into this structure looking like a searchlight. This weighs 14 tons and was the actual radar head. In the picture, up here is a cine camera, I think I'm right in saying, which was used for the fly-past experiments where a Lancaster and a Mosquito did trial flights and tracking experiments went on. While the radar people were busy at work, the circuitry and computer people were hard at it, designing a memory system and designing the basic logic circuits, a family of logic circuits, which physically, at any rate, stretched the technology. There's a printed circuit board measuring something like 5 inches by 3 inches. It's glass. It uses plated through holes, deposited resistors. Those are sub-miniature pentodes on it. Really state-of-the-art implementation of circuit package technology. So that by 1950, the computer, the 152 computer that put all these parts together, did exist. Here it is. The things in the front are actually the film reading cameras, because in the photograph the computer is shown analysing the tracking data. You can see that although in Lewisham they didn't appreciate anything about electronics, certainly in Borehamwood by these days, I mean, that picture says it all, stuffed full of pulse technology and all the state-of-the-art goodies you can possibly have, perhaps even overstretching the thing because the reliability was not too great. Let's leave that 152 computer in your minds and switch back to the next, the other person who was there to make a difference in Elliot's, namely Liam Bagrit. Well, he was an industrial entrepreneur, and the picture shows one of the workshops of his company, B&B Swift, at the end of the war, and he was particularly proud of the assemblage of gear cutting and lathes, etc. that he had. He wanted to expand both the premises and the markets. In order to expand the premises, because he'd done work, his company had done work for Short Brothers at Rochester, he got to know that the Rochester premises of Short Brothers at the Airport Works Rochester were coming up for grabs, and he wanted to put in a bid to get some space there. And in a way, Elliot's was a vehicle for, in order to achieve that, which he did. He started occupying space there in 47. By this time, a reverse takeover had happened between his company, B&B Swift, and Elliot's, and at that point, Liam Bagrit set about acquiring new technology, and he did this by licensing products, usually from America. Products such as the Fisher valves, valves of all shapes and sizes that soon became known throughout the world to control fluids in oil processing, oil refineries, and all sorts of other industrial processes. So with 3 or 4 licensing agreements, he was all set to pursue what had become his ambition, to really revolutionise process control in industry, what later became known as automation. And his ambition, I suppose, got the first major realisation when in 1950, I think this was the end of 56 or early 57, Elliot did the control and monitoring equipment for Cool Hall nuclear power station, which was the first nuclear plant to come online to a national grid. There are no computers as such involved there. These are chart recorders, data loggers, alarm sensors, etc., etc. The basic vocabulary of control at that time. But it was clear to Leon Bagrit and his technical advisor, Lawrence Ross, that computation equipment was needed for the next stage of automation. Let's indulge in a little forward thinking, since we're on Leon Bagrit and his ambitions. The three original Elliot plants, factories, well, Lewisham there in South London, then Rochester and Borehamwood here. By 1964, which I guess is the sort of the zenith of the group, there were a number of other large establishments in the UK, and the total, some 50 centres of business in the UK and some 40 centres outside the UK, employing over 22,000 people, and the profits before tax of just over 4 million. Again, just to look further ahead, to an outsider in 1964, it looked as if Elliott-Automation was on a roll, especially as when in 1967, when Kosygin, the Russian Soviet premier, paid a visit to this country. Remember, this is the Cold War. Russian leaders just didn't visit the UK. And here he is on a brief visit to London, made one trip only outside London. Where was it? It was to Borehamwood. So here is the honoured guest at Borehamwood. Here is Leon Bagrit. He was a knight by then. And here is a chap on the right who we will hear more of in a moment, Andrew St Johnston, who headed up the computer design and production outfits at Borehamwood. Okay, let's say a word of warning, because things under the surface weren't so happy at all. Let's put it all, though, do a recap so far about the company history. The first phase was really getting Elliot into profit, building up the expertise at Borehamwood, making the 152 computer and other classified projects work. So at that stage things were set in a reasonable direction. And by 1956, Elliot had begun to go into the commercial data processing market, which is one that is completely different from the defence and scientific market that they've been in hitherto. And the design group, the computer group at Borehamwood was stretched. Everybody was stretched. They'd been working their socks off producing a number of designs, more of that later. And Leon Bagrit arranged a marketing agreement with NCR. And so from 1956 onwards, quite often in the trade brochures and newspapers of the time, you see computers called National Elliot computers. Well, this was because the marketing in the commercial data processing sector was done by NCR of devices built at Borehamwood by Andrew St Johnson and his group. 1957, the company's name was changed to Elliott-Automation. I see, there we are. Elliot was very proud of the fact that by 1961, half of all new computer deliveries in the UK were made by the company. one should take this with a little pinch of salt, because it wasn't half in value, it was half in number. And certainly by 1962, when IBM really made inroads into this country, things were not so happy. And although by 64, as it says here, profits were at the highest point, probably Elliott's only had about 10% by value of the UK computer market. IBM had about 40%. And it should also be pointed out that Elliott-Automation did a lot of other things besides design computers, and computers as such, the hardware of computers, probably never accounted for more than 10% of the company's turnover, a very valuable 10%, but nevertheless not the whole story. Well, the period of mergers and takeovers was to come next. By the approach of 1966-67, the company's amount that it spent each year on interest repayments and capital depreciation had grown and grown in the background. It had doubled before, between 64 and 67, and things were not good. And for various reasons, which if you want to learn more, perhaps you would look at the book, there was a merger with English Electric, and very soon after that, it all kind of collapsed, in the sense that the UK's mainframe computer companies were all, roughly speaking, put under one heading, ICL. In terms of Elliott products, actually it was only one make or series of Elliott's computers that was put into ICL, and the huge majority of the rest of the company went to GEC, and GEC computers continued. The end of the story, to bring it up to date, was that GEC split itself into two parts, with the defence and aerospace bits forming BAE Systems, which is clearly still with us today. The rest became Marconi plc, which in 2002 posted the largest corporate loss in British history up to that point, I think about £5 billion. And some short while later, the remains of Marconi today are with Ericsson and Tenet, but BAE Systems is still trading strongly. So, that's the background of the computer business, of the company business. Now let's go on to consider the computing landscape. And it's important to make the point that this is analog as well as digital. And it's fascinating, has been fascinating to me to learn of the different transition periods from pre-digital computers to the uptake of digital computers in various applications areas. To take an extreme, if you consider the top bar, which is aerospace applications, they were roughly speaking the last to fall to the digital phenomenon, and it's not hard to guess why. In an aircraft, you need a machine that's compact, robust, reliable, etc. And in the 1950s, machines were not compact, robust, reliable. Furthermore, there are two sorts of aerospace applications in general terms. There are the flight control section, where you're dealing with engine behavior and the aerodynamic stability, and that was the last to resist the move from analog to digital. Rather sooner in the move was the other section, mission systems, navigation, target location, weapons deployment and aiming, etc. At the other end of the story, the science and engineering fraternity saw some point in moving to digital computers quite early on. That's not, it has to be pointed out, all of science and engineering. There are special cases of simulation, particularly missile simulation, nuclear power station simulations, where analog methods were proved much more cost-effective for longer. Okay, the button that I keep pressing, and I will press, and this is to set the digital activities at Borehamwood. We're on to digital now, in the context of other early computer groups in the UK. And roughly speaking, the colour code of this slide is that blue represents the research phase of each timeline, where, roughly speaking, a one-off computer, a prototype, was built, and then the red signifies the move to commercial, fully engineered, commercially available products. I won't go through all these little blips. Every little diamond indicates another type of computer bursting into life, and we'll see what all these little diamonds stand for in the Elliots. To take one example that I'm sure most of you know about, at NPL, Alan Turing had some ideas which eventually saw the light of day in the Pilot Ace, which in due course became the English electric Deuce. And there are similar stories of the other lines in this diagram. Notice that if I've got the diamonds correctly, that the first commercially available production computer was the Ferranti Mark I. This is a UK-centric slide, but actually one shouldn't be too ashamed of that, because the UK did do much of the pioneering work. Those two little diamonds that have appeared in green at the bottom represent a token of what the rest of the world was doing. Actually, the first non-British computer, stored program electronic general purpose computer, that was probably the CSIRA CSIRAC computer in Australia, November 1949. The first of the many American projects to burst reliably into life was probably the SEAC, Standards Eastern Laboratory Computer in America. And of course this was followed by a whole host of other American machines that we haven't the time or inclination, actually. So, what are Elliot computers? I'll show you the photos of them in a minute, but just to put the facts down. These are not quite in chronological order. I have grouped up in this first section of the table the projects that were whose goal was primarily a defence application. They were usually for a special task, like shipboard gunnery control, and usually there was one of them, and not much feed through into the civil arena happened from many of those machines, but we'll show you examples of technology that did feed through as we go on. There's one machine for which I do not have a photograph. Indeed, nobody can find a photograph, so I might as well tell you a little bit about it. And this is the one that Elliot called the 311 project, and its final name was Oedipus. Oedipus, why Oedipus? Well, OED, dictionary, and at the heart of this machine was a semiconductor associative memory, content addressable memory. This machine was built for GCHQ at Cheltenham. Elliots were, to start with, the main contractor, but in the end they were one of three subcontractors, of which Ferranti was one, and the electronics department at Cheltenham was the other. What problem did it address? Who knows? But my guess, and I should emphasize this is my guess, is the decryption of super-enciphered code words, whereby if you've got a message to transmit, you first of all go to a code book and look up a single numeric group that stands for the word or phrase. So if you want to send the message enemy convoy in sight, there probably is a single number or a series of digits standing for that. You then go to your one-time pad random numbers, and you select the next random number, and you add the code book number to your random number, and that's the thing you transmit. And of course you tear off the sheet of your one-time pad, and next time you come to do the process, it's a new random number. So quite a tricky problem, and if you want to look at how Oedipus did it, I say this is where I say read the book. You have to read the book. All the others we have photographs for that I'll show. The number build, I should say, records are notoriously unreliable when it comes to deliveries. And indeed, a lot of the existing Elliot records just say customer undisclosed. So these are my guesses in this column of numbers built. And today, in today's terms, these numbers look ridiculously small, but one has to set them in the context of how many computers worldwide, or certainly in the UK, existed in those days. I think numerically the most successful was the 900 series and the developments of that family, which went in on certainly until the late 70s and numbered thousands. We'll see one or two pictures of those in a while. A word should be said about the people, the hard-working people, the unsung heroes, and every company has its unsung heroes, that made this possible in the early days. Now, it's a very interesting photograph. This is the computing division, and that's all there were. These are the white and blue-collar workers, etc., in the computing division in 1952, 1953, plus one person. And the person who was not a member of the computing division is Charles Owen, who at that time was in the circuits division. The reason why this man, who was an outstanding engineer, was included in the group was to do with schemes, politics, ambitions, hopes and fears of the leader of that group at that time, Bill Elliot. Bill Elliot had arrived, although he's no relation to the founder of the company, Elliot's. Bill had arrived in 1948 to start the computer division. And it's interesting that at Borehamwood there was no computer division in the early days. The nearest we can come to it was a theory division. So by the time this photograph was taken, the computer side at Borehamwood was beginning to get some support from the National Research Development Corporation, NRDC, and things were on a roll as far as the leader of the group, Bill Elliot, could see. However, the company itself was still a bit dicey, and in 1952, John Coles had resigned to go to Cambridge. And for various reasons, Bill Elliot felt that the best thing to do to preserve the expertise that they'd assembled by then was to try and persuade his colleagues, his group, to move to another, a well-founded company such as Ferranti. He didn't succeed in enticing away too many people, actually, and of the people shown in this photograph, Charles Owen went with Bill Elliot when Bill Elliot left in 1953. Harry Carpenter left as well, but not specifically to join Bill Elliot. Those are photographs of engineers, and I need to show photographs of some software people because one can't leave them out of the picture. But in truth, there wasn't much software going on at this stage. Companies didn't provide software with their products. So I've just chosen two people, that's passed on, but they're tokens of all the other unsung heroes, particularly on the software side, that underlie this afternoon's story. On the left is Ed Herson, who joined the company in 1947 and won his spurs, as it were, in the axis transformation algorithms for the 152 computer. And on the right, Dina Vaughan, later to become Dean of St Johnston, described as a formidable programmer, an ace programmer, who founded, when she left Elliot, founded the UK's first software house and went from strength to strength in Vaughan Systems, being given a fair amount of programming to do for Elliot projects, particularly process control projects. Her name will come up later. That's a rundown of the digital side. What of analogue? Well, this is a photograph of the Lewisham factory. And if you remember, I pointed to a sort of black pointy building at the right of the photograph of Lewisham and said this was for the Admiralty's special purposes. Well, the special purposes were to produce analog gunnery fire control computers, and here is one such analog computer under test. This thing here, in the quite large, quite heavy. You can see this sort of thing to this day. It looks like that if you go to HMS Belfast. Into this room when the ship was in action were one officer and 12 ratings, eight of whom would be round this and another table following pointers and doing what you had to do with analog computers in those days. I couldn't resist, although it's in a sense a sideline to my main theme this afternoon, I couldn't resist telling you what immediately followed this sort of analog computer. Alas, Elliot's was not really involved so much in the follow-on, which was an attempt to bring some form of electronics into the analog world of gunnery. By the mid-1950s, there was a system called Flyplane, which was much less ambitious than the MRS-5 of Elliot, of the Borehamwood Lab days. In the centre of it was 6 racks made by Ferranti of electronic analog computing circuits, not digital, still analog, an interface with a bit of electromechanical stuff still to interface with guns. We won't bother to go into the details. That's the radar system that looked like that, and this gear occupied basically 2 compartments down underneath the bridge. So back to the main theme, Elliot. Elliot's produced a number of analog computers, and they're listed here. You'll see that a lot of them were to do with defence. If Elliot had failed to pursue their track record in the naval sphere, they certainly pursued it in the aerospace sphere. This computer here, TRIDAC, 3-dimensional simulator, was interesting, and although I guess most of the audience are digital freaks, I can't resist at the moment a picture of TRIDAC because it was, and perhaps even still is, the world's largest analog computer. It had 8,000 thermionic valves, 2,000 operation amplifiers, loads of hydraulic actuators and servo mechanisms, etc. Cost £750,000 then, perhaps £15 million then. It looked like this. Well, this is the twin buildings which housed it. You can see on the left building lots of hydraulic pumps. There were 2 pressures, low pressure and high pressure hydraulic servo mechanisms controlled by electronics, racks of amplifiers, and here on this side more operational amplifiers. And this photograph is part of the control room of the TRIDAC computer as installed at the Royal Aircraft Establishment, Farnborough. Well, it was installed in 54, I think it was not actually working till 55, I've been unable to find much about what it did at RAE. It was part of everything that went to the 4-minute warning. You may remember that in the Cold War, we, the populace, were reassured with this phrase, 4-minute warning. Well, part of that, that's the main part of that, relied on TRIDAC doing its job. Real-time simulation of a missile and an interception. Quite something. Just going back, there was a cut-down TRIDAC installed in at Woomera in the Australian guided weapons research establishment, which was not real time. It was 10 times slower than TRIDAC, but somehow it was more effective operationally. I think the Australians took it, added to it. Obviously, Woomera was producing a lot of exciting work, exciting films, and that was one Elliot success, perhaps the major Elliot success in those days in Australia. Okay, press on. So, picture gallery of all of these to give you some idea of what they look like, and a little bit every so often on the applications. Not quite in chronological order. The 153 computer, which was installed at Earton Moor, Scarborough for GCHQ in 1954, the job of that computer was the rapid calculation of direction-finding fixes. Listening stations, British listening stations throughout the world, would be eavesdropping on all sorts of signals emanating from the Eastern Bloc, down to single-track tank wireless transmissions. Data would be sent by teleprinter link to Scarborough, and plots would be worked out. When the system was manual, it took about half an hour for each set of data to be plotted. And then, of course, that was still in graph form, and you had to somehow encode that up to retransmit it on to the people who needed to know. The Elliot 153 could do the job in 10 seconds, and since the information was in digital form anyway, the results could be sent out by teleprinter to where they were needed. I'll show you a picture of the 153's architecture somewhat later this afternoon. Its architecture followed the 152. With a big difference that this was much more reliable. So that was the 153, and now for something completely different. A year or so before that, indeed in December 1952, an in-house, more or less hand-built computer called Nicholas had burst into life. This was built in the theory group at Borehamwood. It was built because the theory group was awarded a contract by RAE to compute trajectories for a guided bomb. And it occurred to the theory mathematicians and their human computers, people, usually women who turn handles on desk calculators, that it would be much more fun to build a machine to do these calculations, and in the end it would be cheaper. And they were very fortunate in having a good contact with Charles Owen, the circuit designer. The other good fortunate thing to happen at that time was that Elliot scientists had developed a particular kind of memory called nickel electromagnetic magnetostrictive delay lines, something like that, nickel delay lines. And so the nickel delay line technology was first put to practical use in this computer, very much homemade. You might just see that this is a wooden frame, and you might just see this fire extinguisher to hand. So there was Nicholas that had a long and useful life in-house and was hired out to to outside organisations and did some of the early flutter calculations. A year or so later, in 1953, with the help of a contract from NRDC, the 401 computer burst into life. This was, it was a breath of fresh air in a way to the computer markets, because up to this time, the only available computers on the market had been the Ferranti ones, which were beasts, huge beasts, powerful, costing £95,000. There was a need, NRDC felt, for something that was cheaper, more robust, to address the lower end of the market. And the 401, and it's this is the prototype, its industrial derivative, the 402, were of the order of £25,000, I think. Relied heavily on Elliott's package technology. Indeed, if we take the covers off, you can see what's inside. These things looking like books in a bookshelf are the circuit packages. The main store, it did have nickel delay lines, but the main store was a disk, and here's the disk and disclosure. This is probably the first machine to be taken to a public exhibition and wielded to the exhibition for public show, and this happened in April 1953, and made an immediate impression on the market. And from it, as I say, the 402 was built, of which 11 were sold. The 402 looks more or less on the outside like the 401, so I haven't a picture of it. Meanwhile, the Woomera people in Australia, they needed a digital computer to analyse the mass of data that was coming off their test range filings. And Elliot got the contract and built the 403 computer, which in Australia goes under the name REDAC, Weapons Research Establishment Digital Automatic Computer. Actually, it is in two halves, REDAC and REDOC. REDAC was the first one, first part to be delivered, and was a standalone computer. But it alone could not handle the vast amount of data needed to be processed. And so a special I/O processor had to be built that interfaced with the top cabinet. This was called REDOC. This had two magnetic tape decks manufactured by Pi. Not entirely satisfactory. It was quarter-inch audio type tape, but in those days the provision of tape decks was a big issue. For example, the Lions Leo computer that wished for tape decks, in the end, could not get anybody to develop them satisfactorily. So it was a bit of a risk to have this form of tape deck. The backing material has been described as toffee paper. It was not too reliable. Another requirement was for a line printer, and this is a ball line printer which required some ingenuity to drive at high speed. The contract also required plotters, graph plotters, and some imaginative engineering on Mufax fax machines equipped the Elliott 403 with graph plotters. This machine did have some consequences for the commercial, the civil arena, because I think it's right to say, and there are those in this room who can comment yay or nay, this really focused Borehamwood's minds on handling bulk data. So the problems, although this is scientific data, the bulk data handling problems were the stuff of which commercial data processing installations are made of. So this was good experience. And the experience came to fruition in the Elliott 405 computer, 1956, marketed by this time by Elliot. So you can see the phrase National Elliot on the cabinet. I think 33 of these were built. At the end of the 1950s, this machine was probably the best of British when it came to electronic data processing for commercial organisations. I say that with some hesitancy, but nevertheless, when the Royal Army Pay Corps commissioned, went out to tender for a digital computer to take over from the 800 or so Burroughs desk machines that had been cranking away doing the accounts for something like 250,000 soldiers. Of all the various firms that tendered, only two made the shortlist. It was the IBM 705 and Elliott 405. Elliott proved not really up to it. In fact, one had to have an installation of 3 Elliott 405s to have the total throughput, etc., of one IBM 705. But curiously, in cost effectiveness, the sums were rather more balanced. I just mentioned this to say that although Elliott's, as we shall see, and as many people have said, failed to capitalise and exploit the commercial DP market as we turn into the 1960s, there was a time when they actually led the field in the UK. Next up was the Elliott 800 series of computers. Transistors, reliable, or more or less reliable junction transistors, had arrived by this time. Of course, the early junction transistors were not high frequency, nor were they powered. So there was some ingenuity had to be exercised in order to use the transistor as it existed in the late 1950s in digital machines. And a series of Elliott machines, starting with the 801 in 1957, 802 in 1958, 803A, 59, 803, 50, 1960, all improvements on this transistorized computer that was perhaps for the first time truly portable. You could wheel it into a room, you could plug it into a single 13-amp socket, and it was reasonably priced. And it revolutionized small and medium laboratories, universities, particularly though the process control automation world. This photograph shows an Elliott 803 in the Houses of Parliament. This was a time when Sir Leon Bagrit, mid-60s, he was becoming a persona. He was, if not a friend of Harold Wilson, certainly dining with him on occasions, and it was not surprising that Elliott managed to install their equipment for a short course for MPs in how to program. It's not recorded whether the MPs benefited at all. I believe it's an Algon. I'll say something more about Algon later. But to move on and move ahead a bit, this is a 1967 picture. The advent of small, robust, reliable computers really had a significant effect in process control. This picture shows an Elliott installation in the pharmaceutical company Dista. I need to look at my notes to tell you the actual figures here. It's batch fermentation of antibiotics, penicillin, etc., where the control of the fermentation process, temperature, etc., becomes quite critical if you want yields. The total installation cost about £100,000, of which the central processor was only perhaps 20%. All the other I/O sensing devices, etc., accounted for the rest. And this and hundreds more small, medium, and sometimes large industrial processes in the 1960s began to benefit from the digital technology. Elliott's took the idea of digital technology further in conceiving what they called the articulated control hierarchy, whereby you have a common bus structure and both analog and digital modules, signal processing modules, number crunching modules, can be put to work and configured to suit a particular industrial process being controlled. And the background picture shows a large, perhaps the largest arch installation on the shop floor being commissioned. Here is a member of the low end of the range, a direct digital controller, which can more or less be wheeled in next to a particular process. To go on with the computers themselves, the mainframes, if you like, we've now reached 1962, where Elliott's produced a enhanced, a high performance version of the 800 series computers, software compatible, but going rather fast. This computer is the first production one destined for Tasmania. The central bays of the computer are here. And this thing here, interestingly, this kind of whiteboard, is an engineer's control and monitoring panel used before finding it during commissioning. You may remember that in my previous list of computers, the 502 had been mentioned as a defence-oriented computer. Here is the 502. Is nothing to do with the other 503. This computer was a high-performance, asynchronous machine designed particularly for good interrupt handling and process switching performance in the control of radar and allied applications. First one installed in RRE Northern, testing out the UK's air defences, fighter marshalling, and threat detection by radar. There's at least one member of the audience who I'm sure could tell you more about this. It is secret, and so over to that person if it comes up in questioning. The computer itself is the central bay of cabinets. The other cabinets in the picture are the interfaces with the radar equipment. The Elliott 900 series computers were a deliberate attempt to produce rugged mobile computers for the military market. And one of the first drivers for this machine was artillery control. FACE stands for Field Artillery Computing Equipment. The actual 920B computer is in this steel case here, built strong enough so that soldiers could use it to mount up, to step on it, to get into their tracked vehicle. It could also be put in Land Rovers. The one you've seen is an artillery gunnery command post capable of controlling 10 guns, and this chap here is doing things, who knows what he's doing, to the guns. And this looks like Prince Charles here. I'm not sure that's quite right, but he's obviously a keen chap. There was some fallout, some fallover for the civil market of the 900 range, and here is a 903 computer. There's also a 905. As I hinted earlier, the 900 series computers had a long and successful life. They appeared in many guises. In the end, not looking like computers at all, as science fiction would have them, and that's because they usually have to fit into racking. This one is an airborne computer. They have to fit into particular spaces inside vehicles, inside rockets, inside airplanes. The 920M dates from 67, and the 920 APC dates from 1976. I was very fortunate to have the services of Peter Hearn who unfortunately can't be here today, in writing one chapter of the book, the most interesting chapter on airborne aerospace digital electronics. And if you're interested in that, I thoroughly recommend that you read it. To give you some idea, and it is only a general idea, of the opportunity for digital electronics in the aerospace industry, this shows the mostly analog, actually, equipment that goes into a VC-10. All these boxes made by Elliot, they're to do actually with the line landing and the aircraft aerodynamic stability. Now imagine what a similar picture would look like for a fighter aircraft. Of course, they didn't take the sort of pictures I would like to show, at least they haven't shown them to me. But you can imagine a similar selection of boxes to do the inertial navigation, the head-up displays, the ailing systems, looking after signals from sonar buoys, looking after magnetic anomaly detections, all the sorts of things that the modern aircraft have to have in them to make them operationally effective. And nowadays, all of them, or most of them, probably all of them, using digital electronics. And in the 70s and 80s, many of them using 900 series computers or offshoots of them. So, as I said before, although Elliot's failed to continue their naval record of fire control, etc., they certainly made it in the aerospace sense, and we see that today in Rochester, in British Aerospace. The traditions of technical excellence that were born in Borehamwood exist today in BAE Systems. Back to something perhaps less exciting. The last product of the Elliott-Automation group in terms of mainframes was the 4100 series. As always, around about this time, and we're talking about 1965, 66, when you take a photograph of the computer room of that era, the CPU cabinet is tucked away. It's the most uninteresting thing to photograph. What you see in most of the photographs is what you see here, the peripheral equipment. And it has to be said that Elliot as a company were rather slow to introduce EDSs, exchangeable disk stores. They were rather slow, and I'll say something about this later, to upgrade their magnetic tape offerings. But they did make it in the end. The 4100 series machines I find interesting architecturally, and indeed some good work was done at places like Kent University on time-sharing systems for these machines. So in some senses, when the takeover came and the disintegration of Elliott-Automation, at least on the computer side, they went out with a bang with a good machine, the 4100 series, the only one of the family of Elliott designs taken over by ICL, along with one or two good peripherals, such as the graphical output units. Although it's not strictly part of this afternoon's talk, I will put up on the screen, because I know somebody from this era is in the room. GEC, towards the end of the 70s, conceived a project that some would regard with a certain amount of derision, but a project that was trying to do what DEC VAX machines did. This is a project that had extreme difficulties, largely because it was a joint project with an American company, AB Dick. Arnold Weinstock did his stuff in forcing down costs. It was a really sad and difficult story, and this machine was launched in 1983. By 1984, 22 of them I think have been sold, some of them to Alvin projects at universities, and then it was chopped by the GEC management who felt that this was a step too far and the GEC computers were really running into trouble. And we're reaching the time now, the mid-end of the 80s, when really it was the end of innovative computer design at Borehamwood. GC computers became, I think, GC telecoms, and that's the end of the story as far as Borehamwood is concerned, in a way, although of course, as I said, Rochester carries on. So just a few minutes, if you'll indulge me, well, you have to let you, just to review some of the things that came out of Borehamwood and to comment on them. I got tongue-tied a bit on the nickel delay line store. Here is a magnetostrictive delay line memory board of the early 50s compared with a Williams-Gilbert tube, an electrostatic memory, and a mercury delay line. The pulses go down, reflected back to that end, which I think came from the Deuce, that particular one. All three devices hold roughly 1,000 bits. The nickel delay line lies between the two of those things in cost. It's not as cheap per bit as CRT storage, but it is a lot more reliable and rugged, and it's also more rugged than mercury delay lines. So this technology, it wasn't the first in the field of memory devices. It was invented because Elliot's Borehamwood found that when they tried to get a lot of speed out of the electrostatic storage, they couldn't really make it go as fast as they wanted. So I think the nickel delay line, which was obviously taken up by Ferranti, was an interesting thing that came out of Borehamwood and tied companies such as that over until the advent of the ferrite core store. We've mentioned Elliott's early use of modular and families of modules. What I hinted at is Elliott's forays into magnetic tape backing stores. In the 1950s, really the UK was lagging behind America in bulk storage, magnetic storage. Elliott's decided in about 1955, I guess, that the most reliable, in a way the easiest thing for them to do was to use magnetically coated film. Film stock, 35mm film stock, sprocket fed, and to record on this surface. The heads need not be in contact with the surface. It was a lot more reliable. If you look at the mean time between fault statistics, it was probably 10 times more reliable than the IBM products of the time, but it was 10 times slower. In its time, I think Elliott's was the only UK manufacturer up until the end of the 50s to be making its own tape decks. In my view, I think Elliott's held on to this magnetic film technology too long and didn't switch soon enough to IBM compatible half-inch, but they did in the end. But at its time, the magnetic film, it existed, it worked, and it worked reliably, so it played a part. Elliott's made a brief foray into what they called mini-long elements. This was just before the TTL, integrated circuit building block, came out. A year or so before you could start buying TTL circuits, Borehamwood encapsulated NAND gates in these little white chocolate boxes of blocks about 2 inches by half an inch by half an inch, and used these modules, especially in I/O equipment and telecoms equipment. They weren't solid-state semiconductors in the normal sense; they were transistor circuits, but they were modules that could be taken out of a box and plugged in for special purpose gear. Elliott's itself did set up their own semiconductor manufacturing process in 1966. I think it left Rothes in Scotland. Many would say a step too far at that stage. architecture, I said that, or I threatened that I would give a diagram of the 152 and 153 architectures where speed was very important. These two machines, the 152 and 153, were serial. They're used for storage, anticipation pulse electrostatic stores. Bit serial machines, the challenge was to get speed out of them. And the way Elliot did it was by going for a low-level functional parallelism where these units could all be multiplexed on the same highway system, so that you could have activity going on in the multiplier, in the ordinary adder, ALU, and in three of these kind of caches all at the same time. And so the example given in the manual is that all this activity can be done by a single 153 instruction. The instruction length was long, 64 bits, more like microprogramming, you might say. To do all this activity on a present-day register machine would probably take 5 instructions. And it's interesting to me, not so much that the rest of the world started going this way, but it shows that Elliot's had a particular job to do in their fire control computers. Speed was at a premium. How do they get speed out of a bit serial machine? Well, they went to this low-level parallelism. I don't know enough about the whole range of architectures existing in that part in the world, but I've not seen any other early computer that uses this sort of approach. It's interesting to just show the system architecture of 405, because here we have the idea of several autonomous units, as it were, that can all be ticking away at once. And there is the idea in the 405 system of one being able to configure a system to suit the particular application, commercial application, extended magnetic tape decks or whatever. For the rest, time is getting short, so I'm not going to go through all these little minutiae. This is for the anoraks. But there were a number of, to my mind, interesting, historically interesting things that one can pick out. How Elliot, for example, used modifier registers. Nicholas is interesting because there is the idea of a primitive extra code there to do multiplication in what was a very simple minimal machine. Essentially, the incrementing of program counter was suspended whilst the machine went through ticking away, doing multiplication and using the other facilities. It is interesting. Algon, of course, Tony Hoare, who sends his apologies this afternoon. In February 1962, what is believed to be the first commercially available Algon compiler. Elliot, to my mind, didn't have so much luck on operating systems, and Tony Hoare was here some while ago giving a lecture in this spot, mentioning the 503 operating system. A little one worth further study is this operating system, MACE, designed for real-time process control applications, designed and implemented by Denis and Johnson, and implemented on 8 separate platforms, not just Elliot platforms, for a variety of control applications ranging from Findingdales to railway signalling, steelworks, etc. It proved very interesting. So if you're an anorak, I can direct you to those things. Well, now time to wind up. What remains of all that? Well, I guess for most of you who worked at Elliot, it's people and places that stick to the mind. This is an aerial photograph of the Borehamwood site about 5 years ago, which is in the hands of a property company. For all I know, it might be blocks of flats now or a supermarket, but at the time the photograph was taken, this whole plot was advertised for rent. The original Admiralty fuse factory is this frontage here, which extended a little way behind and the rest was open ground. So a lot has changed in Borehamwood, but there's a chance that if you went there today you would see the remains of physical remains, but of people. John Coles, one of the seminal influences on the Elliot story. So Leo Bagrit, another seminal influence. And I would like to add to this, on behalf of all the unsung heroes, Anderson Johnson, whose influence and leadership in the computer group was felt and praised and acknowledged by many. So I'll leave you with just this checklist, which I hasten to say, and my wife is in the back row and she will be thankful for this. I am not going to pursue these lines of but somebody could well, or some people could look up these, pick up these lines. Take this one. There exists some tea chests full of Bagrit papers in the United States. Have I been able to get at them? I have not. There's a chance that they may be bequeathed to Imperial College. If that's the case, then this is fertile ground. So in putting together my book, those in the know will see that there's lots of places where I've been obliged to skim over the details because I do not know the evidence happened from there. Similarly, and I suppose related to that, is the B&P Swift company. So there's a whole lot of things that the socio-economists can get at. Those interested in defence, it would be fascinating to know the operational life of some of these computers. Oedipus, for example. Can anyone find a photograph of Oedipus? Certainly the GCHQ librarian could not, nor could the Foreign Office. I guess that's a challenge for somebody. So there we are, David, that's it. I mentioned two things, if I may, that there's a couple of copies of the book on the table at the back, together with some discount forms. The publisher, Springer, said rather damningly, we don't do book launches, but I persuaded them to give us some forms that give you 20% discount, if that's the sort of thing you like. And finally, there are so many, and it's wonderful to see so many ex-Elliot people here today. What we'd like to do, after things have died down, after questions, is, if you wouldn't mind, have you outside in the stairwell and take a photograph. So that's it.
Springer might not do book launches, but the CCS does. Thank you very much. Let's have some discussion. Nice to know who you are. John Brooks.
John.
Could you say a little bit more about the ultimate fate of the MRS 5/152 project? And do you think it was, from the start, an excessively ambitious project, given the state of the technology at the time?
Yes, I think you're right there. I think from the Admiralty's point of view, my guess is the main benefit was the radar, the innovative radar. Reading the reports of the naval people who had sort of liaison with the project, time and again they talk about the innovative nature of the radar. So that went forward. When I look at the picture of the 152 and try and imagine that on board ship, I have problems there. More seriously, the Admiralty, as you may know, curtailed the contract partway through. Why did they curtail it? Well, if you look at the defence budgets of the time, they're decreasing. And it was only when there was the threat of the Korean War and perhaps it was Fort Bell in area in 48, that there was, but Korean War put an upturn to it. So it's not surprising that defence projects were being cut, but I think you're right if you hint that really the whole assembly, the digital electronics, there was so much innovation in the whole thing, and frankly the 152, and there are people in this room who will comment from personal experience, was not the most reliable of beasts. And I showed you the glass printed circuit boards. Well, they had electrolytic creep. They had basic troubles with the connectors on there. There was some reliability issues with the basic building blocks. So if the environment had been different and Elliot had been encouraged to go ahead and produce a production version of the 152, my own view is that they would have redesigned it, perhaps look more like the 153, and would it have been fast enough? I'm not sure. So I can't really answer your question, why was it not taken up? But you must remember that, Vanguard was the last British battleship. Was there another cruiser built? I'm not sure. It was mainly destroyers, wasn't it? There wasn't the stomach, I think, for huge fire control equipment. And in any case, guided missiles were coming along. So that, I think the Navy put its faith in those. Have I said enough?
Yeah, thank you.
I've waffled there.
Pretty well.
Terry Froggatt. One of the things that comes out of your book, and you've touched on it lately today, is the suggestion that Elliot failed to get into the commercial world. Surely I view this as a success, because there will be Elliott-Automation. The 900 series sold in its thousands of years afterwards, and there are so many more ARMs and embedded computers now than there are Intel computers. So really being in the automation world was the right thing to do.
Well, indeed, I might say, where is ICL today? But certainly BAE Systems is strong. But, well, where is the money? I suppose there certainly is money in defence if you can get the competitive, the technological edge. And in things like head-up displays, Elliot really did do some world-class work that kept the thing going. It was hard, wasn't it? It must have been hard in the commercial world, given the background in commercial DP of BTM and those sort of companies. Difficult.
You just said that Bagrit was well known in the upper echelons. I think we should remember that in 1964, I think he was invited by the BBT to give the Reith lecture, and he called it The Age of Automation.
How true, and I'm sorry I forgot to say that. Indeed, you're quite right, and he was known as, in the press, as Mr. Automation. Indeed, yes. And he wrote a book of the Reith lectures. May I wave it at people? It's an interesting book because he's obviously a bit wary of being accused of, machines will take over our jobs, you know. And he goes out of his way to present automation as a force for good. There's a marvellous quote on the cover. I don't know whether he actually wrote the blurb on the cover, but he talks about looking forward to an age where people could retire at 55 and go to the country.
Can I just say that the Borehamwood building is still there in Borehamwood, but it was due to be vacated in September, and so presumably it will be demised soon afterwards.
Yes. If I may say just an aside, I went there in, I think it was 2003, when Marconi was getting out. And that was the time when the men from the ministry came to make sure that there was nothing of deadly importance there. And as you may know, if you worked in Borehamwood, the strong room was down in a kind of semi-basement, and it looked like the vault of a bank. You had this huge door with this huge sort of safe thing, and opened it up, and inside were shelves of documents. And I got permission to go in to the strong room after the men from the ministry had been. But they missed two vital things. What I thought at first was just a packet of envelopes waiting, spare envelopes, turned out to be microfiche copies of the whole of the lot of the early reports, secret ones. So you can imagine me reading the microfiche reader in Ipswich Public Library every time there's the word secret. And the other thing, I managed to sell the visitors' books. Every visitor had to sign in. It's incredibly informative.
It's on.
Yeah.
Okay, Alan Wakefield.
Alan.
Hello. I'm celebrating 50 years of joining Borehamwood this year. But I just put a plug in for your book. I had bought it and I've read it already. And it's an amazing piece of research, gentlemen and ladies. So those of you who haven't read it yet, I certainly advise you to do so. I think the other thing you didn't mention is the gentleman speaking down the front there, very influential in the 1950s and 60s Borehamwood Day. Roger, it's delightful to see you, Roger Cook.
Roger Cook, yes.
And perhaps separately I'll make a comment about the commercial versus sort of scientific selling situation, which very graciously quoted quite a lot of my input to your book on that. And so I think it was a different mindset between the Borehamwood salespeople and the Borehamwood and the NCR, and a different level of understanding, which probably led to the sort of slight failure in that area. But anyway, congratulations, it's great.
Well, thank you very much, Alan. Could I just add a postscript? Is Jerry Mills here? Jerry Mills was for a time working in Borehamwood. He had decided views on how Elliot had failed to take up the challenge of the commercial world. And if he was here, it would be interesting to hear his advice. I did quote from him in the book. Yeah.
I'm David Cairns, and the first computer I programmed was the 803, so that's how I was pretty interested. But I believe, I thought there was some kind of tie-up. You mentioned they weren't involved in commercial data processing. There's a tie-up between Elliot and Lyons Electronic Office, LEO. Did they just make it there? Were they responsible for any development? Was any of the hardware in common, you know?
No, if you think back to one of my early timelines, the central processor of LEO was EDSAC. It came directly from EDSAC, and John Pinkerton from Cambridge, I guess it headed the engineering there. Lyons, a most interesting story, but as far as I know, absolutely no connection between Lyons and Elliot. Anyone know of any connection?
Lawrence Clark. There was a very, very brief connection, which didn't come to anything, but I well remember Andrew and I visited John Pinkerton and I can't remember the chap's name, but one who was actually in charge of that.
Raymond Thompson? No.
Yeah. But we had a very nice lunch in the glider, which was an actual World War II glider that they had on or the fuselage of it, they had on the ground somewhere, and they gave us a very good lunch, but it didn't come to anything.
Thank you.
Third of all the members before we vote. Dan.
Yes, I did a little lecture to the Greater London Industrial Archaeology Society of bits and pieces of computer industry left in London, and I went up earlier this year to take a few pictures of the full-on buildings in Borehamwood. Most significant thing you see looking at a view of that now is a Premier Inn in the background, or was it a travel lodge? You can never tell. But I'm interested in this sort of dichotomy between Borehamwood and Lewisham, because Lewisham is on my patch in southeast London. Was Lewisham essentially mechanical engineering and the sort of gunnery, naval gunnery fire control, and all the electronics happened at Borehamwood, or was there some sort of cross-fertilisation?
Yes, it's interesting that, and I can't give the full answer, but to a first approximation, you're right. After the war, after the gunnery was the analogue gunnery computers were running down, Elliott's, of course, Lewisham continued on the instrumentation side, the electronic chart recorders, load cells for industrial weighing machines, that sort of thing. Some of the nuclear activity, nuclear instrumentation was that took place at Lewisham. Lewisham, well, I believe they did plan to enlarge the site, but they ran into local planning opposition. And I can't remember offhand the dates, but the number of people there began to decline, so the importance began to decline from the mid or late 50s onwards. And really, as far as I'm concerned, and the computer story is concerned, Lewisham really doesn't feature much. And the torch, as it were, the Elliot name, was carried by Borehamwood and Rochester, places like that.
Is that all right?
Yes.
Well, it's Laurie Benthal. I just want to mention I actually started, I think it was 55, in Lewisham on the weighing division.
Yes.
And what we did at the time was to design, there were basically relays and uniselectors, little computing devices to add up weights for cranes. The crane used to lift a large weight and we added it up. And I found it extremely difficult then to design, division on these relays. And so I thought, oh, well, you go to the computing division. I went to Borehamwood, and of course I discovered that actually they didn't do it very well either. they did at the beginning, they did it by software. Later on, of course, and I moved then to actually where the actual computing was done, was at Borehamwood. So really, these were just what was done, at least for what I know, down in Lewisham, was really very simple electromechanical devices. That's one thing. Another thing I think I would like to mention also one of the key people in Borehamwood later, not quite at the top, but that's John Bunt.
Ah, yes.
Because John Bunt, as an engineer, first of all, I would say he's the father of the 800 series, with the idea of having a transistor and a core. This kind of joint electronic circuit, which worked well, and after later on, he worked on it was his idea on the 900 series. So they're both the two very successful series. I know, unfortunately, he died, but I think we should remember him.
You're absolutely right. And if you read the book, you'll find a lot of quotes from John, who is most helpful. And he had, for example, preserved most of the Elliot annual reports, which I now have, and without those I would have not known what I now know. So yes, John was a really helpful person. Yeah.
Philip Soberton. I'm a bit player amongst the bit players in the Elliott-Automation story. I joined them in October 1960, and I only stayed there for about 13 months. But I was recruited to become their first operator in the bureau. They'd been selling commercial services, and I think up until then the programmers had had to operate the applications that they'd sold, and they got a bit bored with this, and they wanted somebody else to do it. Just a comment about the Elliots and Leo. Did they not all come together under the English Electric banner at one point before the formation of ICL?
English Electric, Leo Marconi, you mean? Yes.
And I think Elliott's exit from the commercial world was probably speeded up a bit, because didn't NCR introduce the 315 in the early 60s, and they probably didn't need Elliott's anymore after that, I suspect.
Well, that's right. The 315 was manufactured. It was an American machine, manufactured at Borehamwood. But soon after that, the Dundee factory of NCR was established or enhanced in some way or another. There was no need even to have the manufacturing of the 315 done for them. So yeah, that's certainly another factor.
I'm Sally Whitehead, and my father was Charles Owen, and just wanted to let people know that I have got a few papers. If there's any anoraks amongst you, I've got a few papers from the time from his design of Nicholas, and some information about programming and some sample programs as well. But it's only this much. This is just a photocopy of it. But if anybody's interested in having a look, I brought the copies with me.
May I add that Sally's been most helpful. And if you look at that diagram, Sally found the original underlying diagram that's on the screen now is Charles Owen's diagram of Nicholas. And I've had a stab at trying to identify the subsections of the diagram. It's extremely ingenious logically and would repay study. And it's entirely thanks to Sally that this and the accompanying documentation now exists. And if anybody else in your attic has got papers that you think we haven't seen, it would be a good thing to see them. I should add that I am armed with information given to me over the years by Lawrence, started by Lawrence and by others. I've collected now 91 box files of Elliot papers. I have to say that there were one or two duplicates, one or two letters that perhaps shouldn't be preserved, but the majority of documents are interesting enough to be catalogued and preserved, and the intention is that the whole lot should be passed to somewhere such as the National Archive for the History of Computing at Manchester or wherever. I've approached one or two of these places, the Bodleian is another, Bletchley Park is another. So if you do care to share with us any documentation, rest assured that it will be added to the Elliot collection, catalogued, put in a professional place. I can get my study back. and other researchers will have something to get at.
I'm very pleased with your work.
Absolutely, yes.
Can I finish by lecturing the chair, Lawrence Clark? Thank you very much.
Well, Simon, what can I say? After this magnificent demonstration today of a very large amount of information that's in the book, I think the size of the audience here tells you how much we appreciate, we as an audience appreciate what you've done. I am quite sure that John Coles, who asked me in the first place to write this book, and I failed miserably to get maybe 2% of the way, and gladly, as far as I'm concerned, you took the mantle on, for which I personally am really very, very grateful. And I think Andrew and John would join me in wanting you to have some small memento of this work that you've done, and I hope you'll accept this and think about it whenever you look at it. Hopefully use it sometimes.
Well, my word, I'm speechless. I'm speechless.
If you read the market, it does actually say moving targets.
It does. Oh, wonderful. Lawrence, thank you so much. You've been throughout 10 years a great help in coming up with information that I think nobody else alive today has. And without your help, the book certainly wouldn't have been written. Thank you very much indeed.
Thank you, Lawrence. Thank you, Simon. Thank you for making this a very special CCS meeting.